Hello, my name is Robert Smith and I'm with New River Community College's Academic Assistance, and today we're looking at reaction mechanisms. So this is very elementary, what is being presented to us today. It is the very bare minimum of understanding of reaction mechanisms. If you end up taking organic chemistry at any point in your life, you will learn a lot more about it. It's much more comprehensive than what is shown here. But this is a nice little taste about what is to come. All right, so the reaction between nitrogen dioxide and carbon monoxide is believed to occur via two elementary steps, and the steps are given. Write the equation for the overall reaction and identify the intermediate. Also, what if anything can be said about the relative rates of the two steps? So the first thing that should pop up in your mind is that they gave us what the two reactants are. So we got NO2 and CO, and they're going to lead to something. We're not sure about what the coefficients are yet, but we can figure that out by looking at our elementary steps. So we have two nitrogen dioxides and one carbon monoxide. However, in the products, those occurred in the reactants. In the products, we have one nitrogen dioxide, but no carbon monoxide. So this is kind of like a spectator ion, to go into some future parlance. They're just there. They basically, it feeds itself in the production of that NO2. It's not relevant to the overall reaction. So theoretically, we should only have one NO2 and one CO. Let's see how that pans out. The next thing we want to look for are products that do not appear as reactants anywhere on here. So we have nitrogen monoxide and carbon dioxide do not appear as reactants in step 1 or 2. Okay, so those are our actual products. So NO plus CO2. All right, so if our theory holds that we should have only one nitrogen dioxide and one carbon monoxide, then this equation should already be balanced. Let's test it and see. We have one nitrogen and we have one nitrogen. We have one carbon and one carbon. We have 3 oxygens and 3 oxygens. This equation is balanced, and it is the correct overall equation. All right, so the next step is to figure out what is the intermediate. Well, the intermediate species is going to be the one that appears as a product in one step and then a reactant in a subsequent step. And you can see pretty readily that nitrogen trioxide is created in step 1 and consumed in step 2. So our intermediate is nitrogen trioxide. All right. Now it also wants us to make any kind of declaratives that we can about the relative rates of the two steps. So what we can say about this is that the rate determining step is typically the step that produces the intermediate. It's kind of like a bottleneck. If step 1 goes really, really fast, then step 2 can go really, really fast. But if step 1 is very slow, it holds the key to the product of step 1 is in part a reactant in step 2. So if step 1 is really fast, is really slow rather, then step 2 will be slow as well. So step 1 is called the rate determining step. So step 1 is the rate determining step, RDS. So that's one component that we can think about. The next one, we may want to make a rate law for this. So as far as the rate law is concerned, because step 1 is the rate determining step, then our rate is going to be dependent on NO2. So rate is equal to some K times NO2. And we have to think, is this a first or a second order reaction? Based on nothing that you can readily see in this display, but this reaction is second order. So at the very least you can get to this component and then say that this is X, but X is equal to 2 in this case. It is a second order reaction. There are some clues as to why that is in here, but I think that they're advanced enough that it wouldn't be something that you'd pick up on right away if you're not used to these kinds of things. So I don't think that Dr. Adcock or whoever it is that you have for this class will ask you to do anything other than declare what the rate determining step is, what the intermediate is, and what the balanced equation is. This part right here, you would need more information typically. Okay? And that's all I have for reaction mechanisms. It's a rather short section because it's very elementary. Like I said, if you take organic chemistry, you'll get more than your fill of them. So, yeah, keep a lookout for our videos in the organic chemistry file for more information about reaction mechanisms.